Method, class, block you didn't see, but variable you studied. Okay. See, it is called as modifier. Why we are calling modifier? Because it modifies the behavior. Which behavior? Variable behavior, method behavior, class behavior, block behavior. That means we can apply static keyword to variable also, method also, class also, block also. We can apply to all. Now, but variable behavior you studied. Variable concept only you studied. See, one keyword if I attach, the variable behavior is changed. That is the reason we are calling modifier. By using static keyword, we can create class variables. Class variables, very depth you studied already. Over. Now you are going to see class methods, nested top level classes, static initialization blocks. Okay. Next, write it. Class methods. Class methods. Note down. A method that is defined as a static member of a class is called as class method. A method that is defined as a static member of a class is called as class method. A method that is defined as a static member of a class is called as class method. See, method also same style. Before variable, before method, if you write static keyword, that is called as class method. Before method, if you write a static keyword, that is called as class method. See, a method that is defined as a static member of a class is called as class method. Okay. Same. Note down. There are 4 ways to access class method. First one, directly. Second one, by using class name. Third one, by using an object. Fourth one, by using an object reference. First one, directly. Second one, by using class name. Third one, by using an object. Fourth one, by using an object reference. There are 4 ways to access class method. Already know third and fourth ways are not recommended to use. Third and fourth ways are not recommended to use. Third and fourth ways are not recommended to use. There are 4 ways to access class method. First one directly, second one by using class name, third one by using an object, fourth one by using an object reference. Third and fourth ways are not recommended to use. We can use directly or class name. When we can use directly, when we can use class name, you studied same. Access class method directly if it is present in the same class. Use class name to access class method. If it is present in another class. Use class name to access class method if it is present in another class. If the method is present in same class, access class method directly. If the method is present in another class, use class name to access class method. Is it over? Access class method directly if it is present in the same class. Use class name to access class method if it is present in another class. About variables, you studied no class variables? Same concept applicable. Okay. Now, here I'll write method. Suppose void display. I'll write. Is it instance method or class method? It is instance method. Okay. Just if I add one static keyword, it is which method? Class method. Now, 4 ways to access. Directly, just a display. It doesn't take argument. I'm not passing argument. It doesn't return. Void is there, no? So, display. Directly I called. Okay, this is one way. By using class name, demo.display. By using object, new demo.display. By using object reference, demo d equal to new demo. Next, d.display. That's it. Okay, it doesn't take argument. No arguments. And it doesn't return because void. Okay. Now it is directly here by using class name, here by using object, here by using object reference. 4 ways. See. File, save. Now I'll compile this program. I'll execute. See. Java C demo.java. Java demo. See 4 times. Directly class name, object, object reference. All printed. Okay. Try this one. But when we have to use instance method, when we have to use class method required, I'll explain. So when we have to write instance method, when we have to write class method, I have to explain. Oh, is it over? See, I called directly here just by using method name. Method name only written. It is called directly. Here by using class name. Here by using object. Here by using object reference. 4 ways. These 2 ways are not recommended. Okay, these 2 ways are not recommended. This is when it is suitable if the method is present in the same class. This is when it is suitable if the method is present in another class. Now see, I'll remove these all. Suppose here another class is there, test. Here one static method is there. Now system.out.println hello. Now I want to call show method. What we have to write? Give me answer. Can I write only show? No. If you write only show, it will search in which class? Demo class it will search. Error comes. So if I write only show, error comes. Now how to access this show method now? Test.show. It is valid. Can I write only display? Yes. Method is present in same class. Next. Can I write demo.display? Yes. In 4 lines, how many errors are there? 1 error. That is show. See, that error comes. File, save. If I compile, we'll get an error. See, cannot find symbol. Symbol means method show. Location, demo class. Show method not available in demo class. So if you write like this, what will happen? It will search for show in the demo class. That's what error. If I remove this line, if I write as comment, that line ignored, then test.show, hello printed, display, welcome printed, demo.display, again welcome printed. Like this, if you write this is treated as comment, ignored by the compiler. File, save. If I compile, see, compilation, execution. Hello, welcome, welcome. Okay, write this one. If I write directly, error, because method is present in another class. Is it over? When we have to write instance method, when we have to write class method, that is required. Okay. Instance variable, class variable different. Instance method, class method different. So you studied three types of variables: instance variables, class variables, local variables. When we have to write instance variable in Java program, instance variables, if the values are different for objects, instance variable. When we have to write class variable, value is same for all objects. Then when we have to write local variable, to perform the task. If any calculation part is there, if the variable is depending on another variable, in that situation we have to write local variable. Okay. Now here, write it. If the class contains instance variables, if the class contains instance variable, then use instance method. Otherwise, use class method. If the class contains instance variable, then use instance method. Otherwise, use class method. So once you read this line once again, see what I given. If the class contains instance variable, then use instance method. Otherwise, use class method. Understood this point? What I given, understood or not? No? Understood? Whether you understood or not, I'll check it out. Okay. See. What I given, see, if the class contains instance variable, then use instance method. Otherwise, use class method. So what we have to check? Instance variable is there or not. Instance variable is there. Instance method. Otherwise, no. Whether you understood or not, I'll check it out. Okay. No, this is first this concept, only this one. Local variable only task. Now I'll ask question, give me answer. Okay. Whether you understood or not, I'll check it out. Say integer x equal to 10. I want to write method. Which method you want to write? Which method? Instance method. Okay. Now I want to write method. Which method? Class method. Now I want to write method. Confusion started. See, if I don't ask any question, what will happen? You observe. If I don't ask any question, you will feel you understood. I will feel all understood. Now, once again, read this point. If the class contains instance variable, then use instance method. Otherwise, no. Instance method, because instance variable is there, no? You need to check only instance variable is there or not. Remaining leave it. Instance variable is there, instance method. Instance variable is not there, class method. Now, instance variable is there. So what you write? Suppose now I want to write. Now I want to write method. Which method? Variables are not there. I want to write. Same point. Point what again? Class method. Instance variable is there. Then which method? Class method. That answer there only. In a one line only, question different angle I am asking. In that point only all are present. Whatever I asked. Only first you need to check. In a class, instance variable is there or not? See. If it is there, write instance method. Not there, class method. Okay. Once again, give me answer. Now I want to write method. Which method? Instance method. Now I want to write method. Which one? Instance method. Now I want to write method. Now I want to write method. That's it. Now, like this you have to select. Suppose by mistake, other way if you select, what will happen? See. Now I want to write, which method you want to write? Class method. Suppose by mistake, if you write instance method, what is the problem? You need to create object. If it is class method, if you write, object is not required. Object is not required. Suppose if you write instance method now, for calling method purpose object you have to create. Okay. Suppose. Now, which method you have to write? Suppose if you write class method, here it is okay, but anyhow you are creating object for that. When instance variable memory allocated? Whenever object is created. That means compulsory will create object, no? That's what better to go for instance method. Got in mind? So in a program, instance variable is there. Compulsory you have to create object. Otherwise no memory for that. You are creating object. Anyhow you are creating object. Then why class method? Write instance method only, call with instance only. Like that. Suppose in your program variables are not there. Now which method you have to write? Class method. Suppose if you write instance method, again object you have to create. Instance method if you write, for calling method purpose object you have to create. That object memory wasted, object reference wasted. That's what you have to select like that. So while developing projects, first you need to see instance variable is there or not. If it is there, go for instance method only. So maximum places instance variable present. Then we have to use instance methods only more. Class method very rare situation. Okay. Maximum programs, maximum project, instance variable required. Then instance variable, instance method you have to write. Class method usage very less. Okay. Now that is about class methods. Okay. Static keyword, class method. See, by using static keyword, we can create class variables. That is already you learned. Class methods, just now you learned. This is nested top level class. This is today you cannot understand. It is the one type of inner class. Inner classes time I'll explain. Okay. It is static initialization block. It is after constructors you will understand. After constructors. So after constructors I'll teach. About static keyword not completed. Still two more concepts I have to explain. How to create nested top level class, how to write static initialization block. That later I'll explain. Okay. Next, one code snippet I'll write. What will be happen? Give me answer if I compile and execute. Okay. Integer x equal to 10. Okay. Void show. Here demo d equal to new demo. D dot show. Here system dot out dot println d dot x. If I compile and execute, what will be happen? Think yourself and give me answer. If compiles, if executes, what will be the output? If not compiles, if error comes, where is error? Y error. If not executes, where is error? Y error. You have to explain. If compiles and execute, what will be the output? If not compiles, where is the error? If not execute, where is the error? The error reason also. Now, first of all, will it compile or not? Yes or no? Yes or no? How many people answer no? That means remaining people answer yes. No. Okay. Now, how many will answer yes? But remaining. Okay, take you on. You want some time? Think yourself and you answer. If compiles and executes, what will be the output? If not compiles, where is the error? If not execute, where is the error? The error reason also. Object main method. That's why error. Any other? Your answer can be right or wrong. Think yourself and give answer. Now, first of all, how many people answer it compiles? How many people answer it compiles? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 members. Offline, online, 22 members. How many people answer not compiles? Okay. So almost what is happened is 30% people given compiles, 30% people given not compiles, and remaining people not given answer. 40% people not given answer. More than 40. So that meaning if I conduct exam, blank paper will give. That meaning. Now, those who given not compiles, in which line error is there? Line number 6 error. Why error? D dot X is error. Why? Object reference is in a main method. What is it? D. What is the mistake? This D we cannot access here. Is it right? Yes. D which type of variable? Local variable. Local variable scope is within the method only. So this D is a local variable. You cannot access here. Error comes D related. Okay. D is a local variable in a main method. That scope is limited to method only. Outside the method, if you access D, error comes. That is error. File, save. If I compile, see, error comes, compilation time only. See, cannot find symbol, line number 6. Here symbol place D, symbol place variable D, location demo class. It is there, but it is local variable. This variable is local variable. This variable scope is within the main method only we can access. Outside the main method, we cannot access D. Here error. Okay. Now, first write this code. Error. Because D is a local variable. Error. Because D is a local variable. In a main method. And it cannot be accessed. Error because D is a local variable in a main method and it cannot be accessed. Error because D is a local variable in a main method and it cannot be accessed outside the main method. That scope is limited to main method only. That is the reason error comes. Error because D is a local variable in a main method and it cannot be accessed outside the main method because scope is limited to main method only. Is it over? Now I'll explain. See, suppose if I write like this, what will happen? See, actually this is X is which type of variable? What is? Instance variable. X is instance variable. D is local variable. D is local variable. D also we can call it a variable. Already you studied. Object reference also called as variable, but reference type variable. Okay. Now X is which type of variable? Instance variable. How many ways to access? 2 ways. What are those? Object reference. That is you studied. Okay. Can we access X local variable instance variable directly? No, we cannot access. Okay. Now here system.out.println X I am writing. What will happen? See, file, save. I'll compile. Successfully compiled. I'll execute. Successfully executed. We got a 10. But I said instance variable only 2 ways to access. Either by using object or by using object reference. We cannot access directly, I said. Okay. Here also it is not directly. For you appears like a directly. But actually it is not directly. Here object reference is present. It doesn't appears to you. I'll show you. Okay. For understanding this one, 2-3 examples required. Then you'll get a clarity. That concept is called this keyword. Note down. Before program only this point you have to write. Note down. It is called as an object reference or reference variable. It is called as an object reference or reference variable because it refers an object. It is called as an object reference or reference variable because it refers an object. It is called as an object reference or reference variable because it refers an object. See, it is called as an object reference. This also keyword. But what is this is object reference. Object reference we can call it a variable also, no? Reference variable because it refers object. It always refers current object. It always refers current object. Next point. It is implicitly present in instance method, comma, initialization block, and constructor. It is implicitly present in instance method, in initialization block, and constructor. This keyword, it is called as an object reference. It is called as an object reference or reference variable because it refers an object. It always refers current object. It is implicitly present in instance method, initialization block, and constructor. Okay. Now, you observe what are the points I given. I'll explain. See here. Now, is it instance method or class method? Is it instance method or class method? Main method. Main method is class method. How do you know that is class method? Here static keyword is there. So it is class method, it is instance method. Okay. Now, what I given see? It is implicitly present in instance method, initialization block and constructor. Initialization block not completed, constructor not completed, but instance method completed. No. Now, it is implicitly present in instance method. It is instance method. Inside this keyword present. It doesn't appears. In this, not present because it is static keyword. It is class method. Inside the class method, not present. So, if you write like this, actually what will happen here? I return X only. It is implicitly this dot X. It is implicitly this dot X. For you appears X. For compiler, it appears this dot X. So I am writing X only. That is nothing but this dot X. Okay. Suppose here, like if I write myself, I am writing this keyword. Nothing will happen. See, same output comes. File, save. Compilation, execution. Any changes are there? No. You already studied which is a default package in Java? Java.lang. Suppose myself, I'll write import java.lang.star. Any effect will be there in the program? No. See? Compilation, execution. So, if I remove this line, no effect. If I remove this keyword, no effect. It is like a import java.lang.star. Like that, here also it is implicitly present. So, myself I return X only. Myself I return X only. But implicitly this dot X. It is implicitly present. I'll explain with the diagram. You observe. First listen. Listen. I'll give you time for writing. Demo class loaded. Okay. First demo class loaded. Open brace executed. You already studied execution priority. What is the execution priority? Class variables. Next. First class variables. Next. Static blocks. Next, main method. Is there any static class variable? No, no class variable. Next, static block. Is there any static block? No, I didn't explain also till. Next, main method. So, first demo class loaded, open brace executed, directly comes to main method. In a main method, here first this line executed. In this line, first the right side executed. New. It is a dynamic memory allocation operator. It allocates the memory to instance variable X. X memory allocated. Dynamic memory allocation operator. It allocates the memory to instance variable X. Constructor constructs the object. This is created as an object. Okay. This object referred by D. This object referred by D. What it contains here? Hash code. It contains hash code. Okay. Now, see once again, demo class loaded, open brace executed, main method called, open brace executed, new executed. It allocates the memory to instance variable X at runtime. Constructor constructs the object. That object referred by D. D contains hash code. After this, D.show. Then control comes to show method. System.out.println X. Here implicitly this dot X. This nothing but it is an object reference. What it refers? Current object. Which is current object? Here only one object is there. This object only current object. That means this hash code only stored here. So whenever I call D.show, this show method called with D. The D copied in this. Now here what will be there here also? Hash code. Here also hash code. Now this hash code refers this object. This hash code also refers same object. Then this dot X 10 printed. Now How many ways to access instance variable? 2 ways. What are those? Object, object reference. Here, which one we used? Object reference. But where is object reference? This. Where is this? Implicitly this. I am writing X only. I am writing X only. Implicitly this dot X. So this doesn't appear to you, but this is there. So instance variable 2 ways. Whatever I given notes, that is 100% right. Okay. It is not directly. It appears like a directly. It appears like a directly. Here actually what is there? Object reference. So instance variable only 2 ways to access. Either object required or object reference required. Here also object reference present. It doesn't appears to you. That is only this keyword. This refers current object. But in this program, how many objects are there? One object. That is only current object. If more than one object is there, which is current object, I'll show you. It is example 1. Note down. Example 1. Global variables are not there in Java. Already told. Any global variables are there? Already one point I gave, no global variables in Java. In Python it is there. First note down as it is. For understanding, one more example you have to see. Then you'll get a clarity. It is first example. Total 6 examples are there. With second example, you'll get a clarity. With second example only, you'll get a clarity. Up to that, you should have patience. Okay. With second example only, more clarity comes. With second example only, you'll get a more clarity. Global variable means outside the class. Outside the class, Java doesn't support. Java doesn't support to write variables outside the class. No global variables in Java. Is it over? Diagram also write it better. This is also write it. This dot X implicitly present. Because after 1 week, if you open, you'll get a confusion again. At least if it is there, you can understand easily. After 1 week, you may think again, this is directly, you'll think. Directly not possible. Okay. Is it over? No. Now, this is which type of variable? How many ways to access? What are those? Is it directly? No. Here object is there or object reference is there? Object reference. Object reference implicitly present. That is only this keyword. That is only this keyword. So here implicitly this keyword present, that is only object reference that refers current object. Suppose here D1, demo D2, one more object. Okay, D1 dot X equal to D1 dot X plus 3. Here D1 dot show. After this D2 dot show. If what will happen? See, first of all, see, demo class loaded, open brace executed, main method called, open brace executed. Here how many objects created? 2 objects. Then how many copies of X created? 2 copies. Every object separate copy. Okay. So here X 10. This object referred by D1. This object referred by D1. Like this, one more object created. Demo object. This object referred by D2. Now D2. Like this. Okay. Say demo class loaded, open brace executed, main method called, open brace executed, 2 objects created. 2 times memory allocated to instance variable X. This object referred by D1, this object referred by D2. D1 refer this object, D2 refer this object. After this, D1 dot X equal to D1 dot X plus 3. D1 dot X equal to D1 dot X plus 3. It will become 13. It will become 13. Okay, 13. After that, D1 dot show method called, system dot out dot println X. Here implicitly what will be there? This. It doesn't appear to you, but this is there. Okay, this dot X. It is implicitly present. Implicitly present. Okay. Now this dot X. Here how many objects are there? 2 objects are there. But this keyword refers current object. Now this method called with which reference? D1. So this keyword refers D1 referred object. This keyword refers D1 referred object. Okay. Then what is output comes? 13. Output 13. After printing 13, control comes back. Again D2 dot show. This link broken. Now it will refer this object. Now what is output comes? 10. You observe here D1 refers this object. D2 refers this object. This keyword refers current object. If the method is called with D1, then this keyword refers this object. If the method is called with D2, this keyword refers this object. So this keyword always refers current object. Sometimes this is current object, sometimes this is current object, sometimes other one more also current object. If the method is called with D1, then current object is this one. If the method is called with D1, D2, then current object is this one. Like that works. Okay. Now first method is called with D1. That's what 13 came. Later method is called with D2. That's what 10 came. Got it? So D1 refer this object only. D2 refer this object only. But this keyword refers current object. Sometimes this is current, sometimes this is current. Like that. Okay. Write this one. Example 2. Write first. If the method is called with D1, D1 referred object refers. If the method is called with D2, D2 referred object refers. Now output 13, 10. Is it over? See, once again, I'll explain. First, you complete writing. Is it over? See, demo class loaded, open brace executed, main method called, open brace executed, new. It is a dynamic memory allocation operator. It allocates the memory to instance variable X, allocated 10. Constructor constructs the object. This object referred by D1. Again, same style, one more object created, that object referred by D2. Two objects created. That's what two copies created. Because instance variable, separate copy of instance variable exists for every object. So two objects are there, two copies created. D1.x equal to D1.x plus 3. This is modified as 13. This is modified as 13. D1.show. Then control comes to show method. But the show method called with which reference? D1. This keyword refers D1 referred object. What is there? 13. That's what 13 printed. It will come back. D2.show. Again control comes here. Now show method called with D2. Then D2 this keyword refers D2 referred object. 10. Is it clear? Suppose here one more variable. Now first I'll remove this one. 1 minute. 1 minute. Now will it compile? Will it compile or not? Will it execute? What will be the output? It is example 1 only. I didn't change. Example 1 only, no? Example 1. Suppose here integer x equal to 20. This is which type of variable? Which type? This variable, which type of variable? 1 minute. How many people answer instance variable? How many people class variable? Class variable, no one is there. Okay. How many people are local variable? But remaining people? Global variable. Global variable not there in Java. Which type of variable? Local variable. A variable that is defined in a method, always not only main method. In other method also local only. It is also method only, no? Inside a method, local variable. Inside a method is local variable. How many ways to access local variable? One way. That is directly. Now think yourself and give me answer. What will be the output comes? 10 or 20? 20 comes. Because already this type of example you studied. Class variable, local variable, same I given. So it will print 20. See, file, save. See, compilation, execution, 20. In this situation, if you want to print instance variable, this keyword ourselves we have to write. Now 10. So it is 20 here 10. So this keyword implicitly comes, I said, but in this situation it will not come. We have to write. Situation like, say, this keyword, note on, this keyword explicitly required to access an instance variable whenever both instance variable and local variable names are same. This keyword explicitly required to access an instance variable whenever both instance variable and local variable names are same. So implicitly comes. In this situation it will not come. We have to write situation. Okay. This keyword explicitly required to access an instance variable whenever both instance variable and local variable names are same. Okay. In this situation not possible. We have to write. In this situation we have to write. Okay. It is explicitly required in this situation. Is it over? Write this example. Example 3. Example 3. Here you'll get a 20. Here you'll get a 10. This keyword ourselves we have to write. Note down. Example 3. Only one object is there, one example I given. More than one object, one more example I given. Explicitly, one more example I given. Total 6 examples are there. 3 completed. So here only X if you write. Now in this situation, local variable 20 printed. Because for this one, there is no other option. Local variable, there is only one way to access. That is directly. That's what it will print 20. In this situation, if you want to access instance variable, this keyword explicitly we have to write. Then only 10. Then only 10. Okay. So instance variable name, local variable name, if it is same. If you want to access instance variable, this keyword explicitly we have to write. Clear? 3 examples completed about this keyword. Okay. We'll see continuation tomorrow. Tomorrow we'll see. We'll see continuation tomorrow.